Adding complex fractions number 6, we're asked to add 7 plus 5x, 7 over 5x plus 8 divided by 3x. And just start with this argument right here that says if we had maybe like 1/3 plus 1/4, that we know that we can't add these right now because we don't have common denominators. So we find a common denominator here, and I think the one we'd find is probably 12. So we'd multiply this one over here by 3 over 3, right, because that's 1. Doesn't hurt anything. This one by 4 over 4. That's going to give us the same amount because we're just multiplying by 1. But common denominators, we have 4 times 1 is 4. 12ths, right? And then 1 times 3 is 3 12ths. Go back and check. 4 divided by 4 12ths is the same as 1/3, isn't it? So I didn't change anything. 3 12ths is the same as 1/4, right? And now we know that we have common denominators, don't we? So we don't add the denominator, right? We just bring them over, and then we add the numerator. So 4 plus 3 is 7. Why am I showing you this bit of elementary fractions here? Because this will work the same way. This will work the same way. Here we have a denominator of 5x. Here we have a denominator of 3x. So look, I'm going to multiply this side by 5 over 5, and this one by 3 over 3. Before I go on, look at this for a second and see if we're not going to get common denominators here, right? We have 3 times 5x is 15x, and 3x times 5 is also 15x, right? So here we have 15x at the bottom here, and here we have 21. And look, 21 over 15 is 7/5, so it worked out fine, didn't it? Plus 8 times 5 is 40, and 3x times 5 is 15x again, isn't it? Remember, this is not a multiplication sign, this is an x. This is an x. So what are we going to do here? We're going to add. We have common denominators. First thing we check for, we have common denominators. So the common denominator that they share is 15x. And then what do we have in the numerator? We have 21 here, 40 here, for a total of 61, right? So here's our answer, 61 over 15x. The next one is a little bit more complicated, but it makes sense. So let's take a look at it. It's going to bother you. Sorry, but it's going to bother you. It's x over x minus 4 plus 6 over x plus 3. So, going to be really careful here. Here we have x plus 3. Here we have x minus 4. This is not 4x. This is not 4 times x. This is not 3 times x. This is plus. So the factor is this, isn't it? So to get common denominators here, what we're going to do is the same thing we did in the first problem, but we're just going to do it using variables here, right? This one, look, if we multiply this by x plus 3 over here, and this one by x minus 4 over here, I'm not done, but stay with me. Our denominator would be x plus 3 times x minus 4, and the denominator here would be x plus 3 times x minus 4. That would be the same, right? So all we're going to do to make that possible is say x minus 4 over x minus 4, right? Because x minus 4 over x minus 4 is just 1, isn't it? And here, yes, right, exactly the same thing, right? X plus 3 over x plus 3 is just multiplication by 1, isn't it? All right. On the second part, it takes a little bit of thoughtfulness, and when I teach calculus, we really talk about this a lot. Like, how will we make this work? Like, should we FOIL this out? Should we get an answer here? And I always say initially, don't do that. So the common denominator they have is x plus 3 times x minus 4. Right? There's the common denominator, because it's the same denominator over here, isn't it? And I am not going to multiply them. And if you're sitting there saying, well, my teacher said we have to, well, then go ahead and do that. I'm just suggesting to you that I think it's not really necessary, but maybe I'm wrong. All right, we have, and here we're going to do this. We're going to distribute x times x and then x times 3. So x times x is x squared, isn't it? X times 3 is 3x, right? This plus sign right here is this one. 6 times x is 6x, isn't it? And 6 times negative 4 is negative 24, right? I'm going to just gather our like terms. So we have x squared, right? And when we gather like terms, just remember this. The variable has to be the same and its exponential value. So there aren't any other x squareds. This is these are x to the first powers, and these are x to the first powers. So we have 3 of them here, 6 of them here, for a total of 9 of them, right? 9 x's minus 24 all over x plus 3 times x minus 4. All right? So I really do hope that that was helpful. Love to hear your comments. I'd love for you to like my video. And if you're not already subscribed to my channel, please subscribe. If there's some other math you'd like to talk about, please let me know.